So let's just see how we can delete one node from a binary search tree. So here we have one binary search tree. Now if we wanted to delete one node, there can be three cases. First of all, the node can have no child. That means this can be one leaf node that we wanted to delete. Secondly, the node can have one child. And thirdly, the node can have two child. So let's just talk about the case 1. When the node has no child, that means that is a leaf node. So in case of the leaf node, we can just simply remove that node. And this is the easiest way to remove one node from the binary search tree. Now in the second case, when the node has only one child, so like an example here, the node 5 has only one child. Now if we wanted to delete this node, we just have to simply replace this with this single child. So that means the 6 will be replaced with 5, and then so this way the node 5 will be removed. Now let's just talk about the third case, where the node that we wanted to delete has two children. So like an example, we wanted to delete this node 4 which has two children. So in this case, we can replace this 4 either with the in-order predecessor or the in-order successor. So if we perform the in-order traversal on this tree, so first of all we're gonna have 1, then we're gonna have 2, then we're gonna have 3, then we're gonna have 4, and then lastly we're gonna have 5. So here we wanted to delete this node 4 from this binary search tree because the node has two children. So we can replace the 4 either with the in-order predecessor, means the previous value, or we can replace this with the in-order successor, that means the next value. So that means either we can replace the 4 with the value 3, or we can replace the 4 with the in-order successor, that means with the value 5. So here we have the function to delete one node from the binary search tree. So the function takes the root node of the tree and the key that we wanted to delete. So first of all, we're gonna check if the root is null. So if the tree is empty, so in that case we're just gonna return the root. So otherwise we have to find the node with that key value. So if the key is smaller than the root key, in that case we're gonna just look for that value in the left subtree. So here we're just gonna recursively look for the value in the left subtree. So otherwise, if the key is greater than the root key, so in that case we're gonna recursively look for the value in the right subtree. Else, that means if we have found the value, now there can be three cases: either the node has one or no child, or the node can have two child. So first of all, in case if the node has one or no child, in that case, first of all, if the left child is null, then we're gonna temporarily store the right child, and then we're gonna free that node, and then we're just gonna return that temporary right child. Otherwise, if the right child is null, in that case we're gonna temporarily store the left child, and then we're gonna free that node that we wanted to delete, and then we're gonna return the temporary left child. Now in a case where the node has two children, then either we can replace this with this in-order predecessor or in-order successor. So in this case we're just getting the in-order predecessor. So we're gonna call the function max value node, and we're gonna pass the left child. So in this case, because we wanted to delete the node 4, so we are basically passing this left child as a parameter to the function, and the function will go right as possible to get the in-order predecessor. So here we have the function, this is the node, so this is the left child that we have passed as parameter, and it will loop to find the rightmost leaf. So the loop will find the rightmost child as long as the current right is not null. So that means we are basically going as right as possible to find the leaf node which is the maximum value in this left subtree, because that will be the predecessor of this node that we wanted to delete. Also we can do this other way also. That means we can also use the in-order successor. That means we're gonna pass the right child as the parameter, and then the function will go to the left. So it will find the leftmost child from this right subtree, which will be the in-order successor. So we can use either of them, we can either use the in-order predecessor or in-order successor. So here we are copying the predecessor value to the root key, and then we can just delete recursively the predecessor. And after the end of this process, we can just simply return the modified root node of the binary search tree. So here we have the code. So first of all, we have defined the node structure. Then here we have, so create node function is to create or allocate memory for a new node. So this is to find the maximum value in the left subtree or to find the in-order predecessor. Now here is the function to delete the node from the binary search tree. So inside the main method, we have created this tree with the values 4 to 5, 1, 3. So that means we have created this binary search tree. So let's just try to delete this node 4. So here we can call the delete node function, and we can pass the node that we wanted to delete. So here we wanted to delete the node with the key 4. Now after the deletion, we can print our tree. So here we are printing the in-order traversal after the deletion. So you can see before the deletion we have total of 5 nodes, and after the deletion of this node 4, you can see we are left with only 4 nodes, and the node with the key 4 is deleted from the binary search tree. But after the deletion, you can see this is still one binary search tree because the in-order traversal values are sorted. So this way we can delete one node from the binary search tree. So hope you understand the concept. See you in the next one. Take care.